Today we'll be looking at a very important and interesting design pattern, which is the adapter pattern. So this is a very famous diagram representing the adapter pattern. This is our existing system. This is our vendor class. We want to join them together, but this can't fit in. So we introduce our adapter in middle so that these three pieces can be joined together. So in doing so, we have followed closed for modification bit of the open closed solid principle. So if you have not seen that, please refer to my solid principles videos. So we are not modifying any existing code here. No change, and we have introduced a new code. That's all. So we have extended our code base. So basically this is the class diagram of this adapter pattern, but I don't think this will be clear if we see it right now. So we will first look at an example and then we will come back to this class diagram. So this is an example code. So this is some existing code which is already following the socket interface. So what the socket interface is? The socket interface is an interface which the client is familiar with. So hairdryer is our client. It is having a socket reference, and in its needs energy method it is calling request energy method of that on that socket reference. So this socket interface is just defining a request energy method which is called here, and this is the hairdryer constructor. When we provide it a socket reference, it initializes its own reference with that. So it's as simple as that. So hairdryer is our client class and it's familiar with this interface, that is the socket interface. So let's look at this bit of the upper bit of this class diagram. So this is our client class, which is hairdryer here, and it's familiar with this socket interface, and it knows that socket interface has this request method, so I can call it. So it's calling the request method basically. So basically it is here familiar with the request energy method of this socket interface, and it's trying to call that. So this socket reference is an interface, so it can refer to any of its subclasses objects. So basically let's look at one of its subclasses. So any of the subclasses can be passed in the hairdryer constructor by Liskov substitution principle. Cool. So let's look at one of its subclasses. This is some existing code which need not be adapted because this already implements socket and our client is familiar with socket interface. So this US socket is having a request energy method which is printing take the energy. Cool. So this is some existing code. So let's say our client is living in US. So it is using this socket interface. So he's having a hairdryer which fits in this US type of socket. So our US socket is extending this socket interface, and it's implementing this request energy method, and our client hairdryer is familiar with this request energy method. But when a client is going for tourism in India, he comes across an Indian socket, and his hairdryer can't plug in his hairdryer in the Indian socket because Indian socket is not following this socket interface. So it's not implementing this socket interface anymore. So US socket was implementing this socket interface which our client is familiar with, but Indian socket is totally different. Our hairdryer can't be plugged in there. It's having a get energy method which our client is not familiar with. So a client somehow needs to adapt to this Indian socket. So what we want to do is we want to write a adapter class. So this is an Indian socket adapter class. So in Java, wherever you see adapter suffix, that means adapter pattern is in action. So this adapter pattern is implementing this socket interface, which our client is well familiar with. But internally what it is doing is it is having a reference of this Indian socket object. So it is having this, and it is initializing it in the constructor. And whenever the client tries to call request energy method, because client is familiar with socket interface, and socket interface defines request energy method, client will call sockets request energy method. So our adapter says to the client, please call the request energy method, and I will internally transform it into Indian socket.get energy. So client is still calling the request energy method, but I am transforming it into my Indian socket objects get energy method. So this is the trick. So if you want to take the analogy in the real world, the tourist just buys an adapter which does this transformation. So he buys a small piece of metal conductor with just one side is he can put his own US wire, and the other side he can fit that into the Indian socket. So that kind of adapter he can buy. So basically let's look at how the client was using this this US socket. So new hair dryer, new US socket dot needs energy. So hair dryer is being passed a US socket because hair dryer constructor expects a socket. Any of its subclasses can be passed. So we are passing a US socket, and then we are calling the needs energy method of hair dryer. So this is the needs energy method, which internally calls socket.request energy. So a client knows that this interface socket is having request energy, so it will call this. Let's look at how we do it in India. This is how the hair dryer is started in US. Let's look at how we get our hair dryer started in India. So new hair dryer, and then we wrap our Indian socket in a Indian socket adapter, and then we pass this to our hair dryer. And then, because this is a simple socket now, because this Indian socket adapter is following the socket interface, so this part, this whole thing takes place of this new US socket. So this Indian socket adapter is exactly behaving like a US socket would, because it's also following the socket interface, and internally it is well encapsulating an Indian socket object, and it's transforming any request energy calls to Indian socket.get energy. So this is the crux of the thing. I think I've tried to explain it. So let's now look at the class diagram. So a client is familiar with this interface. A client knows that I can call this request method, but then comes Indian socket with other request method. So we write an adapter which is following this interface which our client is familiar with. Hence this adapter class can be passed in the client's constructor, because our client is well familiar with this interface, and this adapter is following this interface. It is basically implementing this interface. But what it is cleverly doing is, it is in its request method, it's cleverly calling the adaptee object's other request method. So it's having a hold on an adaptee object, and it's basically calling its other request method. So I think I've repeated this thing a lot of times, and hope this has now become crystal clear. Thank you, friends.